Hello and welcome to this carbon tutorial where we will teach you how to use a combination of the carbon mesh allowance and carbon crease node to enforce an angle of two cloths that are stitched together on open edges. Now let's have a look at our scene. First we start with a collider up here, on which we have a cloth here in yellow and another cloth in red. The top cloth is bound to the collider, so it's hanging off the collider. Additionally, we have stitched the red and the yellow cloth on this edge together. If you go here, we see group stitching of the top cloth and group stitching on the bottom cloth. These have come together with a stitching node where we apply a very tight stitching. We set compression to 0 and extension to 0.01 to allow a little bit of extension to avoid over-constrained situations. And we have set our equilibrium to 0 as well, so it's a really tight stitch. Looking at the simulation, I'm going to reset and run it. It's very smooth and there's no fighting. Well, this is because I've added a narrow filter. This narrow filter is set between the top and the bottom cloth, same order as in the stitching, top and bottom. And I'm using the stitching constraint to create the narrow filter. Now, if I did not create the narrow filter, for example, if I go back, disable it, reset the simulation, and run this, we will see fighting. This is because our stitching has brought the points on the open edges so close together that they're actually closer than the collision would allow. Because remember, when you have thickness on your cloth, it also is extruded on the open edges. So bringing them closer together and having a stitching, which means your collision is fighting your stitching strength. Alright, so then we just create this narrow filter and it filters all the points on the open edges. We can also visualize this. Let me go ahead and hide the physics row of the cloths. There we go. The narrow filter shows that these triangles of the top cloth are filtered with these triangles on the bottom cloth. So there's no collision between these and we get a very smooth behavior. Let me bring back these. There we go. All right, so let's get started now. What do we need to do to actually apply an angle between the yellow and the red cloth? Well, normally, as you know, angles, like via the carbon crease node, for example, you select an edge group and you say set angle to 5 or 20 or whatever you want. But this needs to be on a non-open edge. The reason being that when you have an edge and it has a triangle on top and a triangle on the other side, you have basically a little butterfly and you can set an angle on that. If you only have an open edge, you only have one triangle and you cannot set an angle on an open edge between a triangle and nothing else. So what we need to create is actually non-open edges here where these come together. And that's what we're going to do by the carbon mesh allowance node. Let's create one of these. Carbon mesh allowance. We will attach it to the group stitching right here. And we will add count to 1. Group, we set to group stitching. There we go. And we immediately see we have created these darts here. And this is an extrusion of the points that are marked by group stitching. Now the width parameter allows us to set the extrusion distance or extrusion width. You want to set this in a way that the height of these darts is roughly the same size as each edge on this mesh. So 0.02 actually works pretty well. You can see it's roughly equal length. It doesn't have to be perfect, just close enough. All right, the angle is our extrusion angle. You can set this anywhere to go around here, if you please. I like to set it to 90. Especially when you have two cloths coming together, it's very nice when you have the darts pointing backwards and then the edges meet nicely. You will see in a second. Now curve type. Curve type open or closed. Default is open because most of your groups here, the group stitching, will not be a closed loop. If your group forms a closed loop, so if we had points going all the way around, then you could set the curve type to closed. Since we do not have this here, it yields an empty result because it detects that there's no closed group. Extrusion type is darted or band. Darted, as you can see, creates these darts or saw teeth. If we set it to band, it will fill in the gaps with extra triangles. This will make this strip stronger and make sure that the saw teeth work in unison and don't point in different directions during your simulation. The one scenario where you don't want to use band, where you actually want to use darted, is, for example, if you have a mesh that gets deformed a lot. Like imagine this grid being turned into a tube. If you roll this up into a tube, right now you can do it because there's nothing in between these darts preventing them from deforming, so from rolling up. If we added band, we would have these extra primitives with surface area preservation and these edges here fighting the deformation. So you would get a fighting between the tube being rolled and these primitives here not wanting to compress, for example. In this case, we don't roll anything up, so banded is better because it gives us more strength. All right, I'm going to place this now between the stitching and the glove top. Now, there are a couple other parameters. Let's ignore this match allowance points, which is very useful when you work in the carbon garment processor, and we've mentioned how to use it in there. But I want to mention new groups. So when you create this, you see two things actually being created. First of all, you have your allowance 17, which is a primitive group. This marks all primitives in here. If you had sent to dart instead of band, you would have less. We only have 9 points in 9 primitives in here. Go back to band from darted, and we go to 17. So these 17 triangles part of the allowance. Additionally, group stitching, as it was before, 10 is now 19. This is because all the points of the allowance were added to your original group from which the allowance was created. If you not want this to happen, you can take new groups. Now on the allowance, we have our group stitching with the original 10 points, and we have a new group stitching allowance with the 9 newly created points. I actually want the original point group to be extended because it fits neatly with my workflow, so I do not take new groups. What does this mean? Now we have in our stitching, instead of 10, we have now 19 points. It is still ordered because the allowance creates the points afterwards in the correct order. And if we now do the same thing for the second mesh, where we also end up with now 19 points in the same correct order as before, our stitching, because it points to the groups, will pick up all the new points, and our narrow filter will also pick up all the new points. And if we now run the simulation, we see we have our allowance here, and if you run this, actually everything is stitched together nicely. We can verify this by just quickly hiding the cloths. And you can see the narrow filter includes these triangles here, overlapping triangles, and I'm not sure if you can tell the small dots, or maybe I hide the narrow filter. You can see the new points of the stitching as well, so everything just falls into place quite neatly and procedurally. Let me hide the narrow filter now because I do not really need it anymore to be shown. All right, let's go back to the simulation and reset. And I should probably show the cloths again as well. All right, as you can tell, we got lucky here that setting this to 90 made this line up perfectly. But you always need to verify if you have two panels come together that your mesh allowance is overlapping. So if I show the other one in wireframe, it aligns perfectly. If I had set that one not to 90, but something else, for example here, what would happen on the first frame, because our stitching is so strong that this point would be forced together with this point, and so on, this one with this, we will create a lot of issues in the scene. So always please make sure that when you have two panels come together like this, that they mesh allowance so that the extrusions line up nicely. All right, this looks great. Go back to the simulation and run. All right, now what do we see here? Obviously, we see our mesh allowance. This is now part of the cloth, which means it's collision geometry, even though the narrow filter filters collision between the two meshes. And in this case, it doesn't really make a difference. You imagine having a scene where this is actually part of a t-shirt that's stitched in a character. And now this new section, this like little strip of the mesh allowance, would actually overlap with other layers of your t-shirt or would overlap with your character. You really do not want this to create any collision. All you need this for is to be part of the soft, the cloth, so that we can set creases on the edges, which were formerly open edges, but are not anymore. So we want to remove these triangles of the mesh allowance from the collision. How can we do this? Well, that's quite easy. As I said before, the mesh allowance create a primitive group called allowance. And on the carbon cloth node, if we go to parameters, in the collision section, we can provide a primitive group of triangles or quads, or primitives that actually collide. So we want all except for the allowance primitives to collide. What can we do? We use a group combine. If you go to group combine now, and create a new group, and now we'll call this group collision. There we go. And now equals, and I want all but surround all of the primitives except for the allowance one, and you can already see this highlighted. The allowance ones are not. So now I have my new group, and obviously since the other mesh is basically the same, I can copy and paste this here, and we get the same result, all but the allowance, the newly extruded triangles. Let's go to the cloths. Select primitive group, group collision, and here as well, the other one, primitive group, group collision. Now we go back to our carbon simulation node. If you reset now, and there they are gone. They're not part of the collision anymore. They're still part of the cloth, so they still have edge constraints and surface constraints, but they're not part of the collision. So when the collision surface or in the collision mesh physics draw, you will not see them. If you go to soft primitives, they will show up again because they're still part of the soft, but just not part of the collision. All right. Let's press L and H to lay out our graphs, press save, because we're in a state where we now have our allowance added. We still have the same flat simulation, but we have all our things in place to now add the crease nodes. Let's add a carbon crease node. All right, we're going to start with the first mesh, group combine, pass it into the carbon crease node. All right, what do we need? Our carbon crease node needs an edge group. What is the edge group? Well, we want the group that's here, these edges here that were formerly open edges, but are now between the allowance and the original mesh. So how can we get this group? Well, we can either manually select it, or we can look at the stitching group that we have in the beginning. We can use a group promote node, go in here. We want to go from points to edges. Our group name from the stitching, we take these. Now we have edges that are automatically created from the point group. We go to include only elements entirely contain the original group, and there we go. We only have these open edges now. Our new name, we call it group crease. All right, now we have our group. We can obviously do the same on the second one. Copy, paste our group promote, plug in here, and there we go. All right, back to our crease. We can now select in the drop on our group crease. And then our crease be attached to the fourth input of the cloth. Let's duplicate this and do this for the second one as well. I press LH to lay out my graph, and now we have our crease nodes plugged in. Well, not much will happen if you don't set this up correctly. So let's look at the crease node. We can do replace, add, and blend of our angles. Well, what do I want to do? Well, I have my allowances set up with a 90-degree angle so that these meshes come in together flat. So I do not want to override that 90-degree and completely remove it. I actually want to add to it. Same with the other one, move to add. Right now we're adding 0. So even if I set the strength of both crease nodes to, for example, 100, I'm now zooming out, reset the simulation, and run this. Oops, my apologies. You know what? We removed the stitchings. That was a mistake. Let's go back. What did we do wrong? Go to group promote again, and we forgot to tick keep original group. We actually deleted the stitching group and promoted it to group crease. Same here, keep the original group. We did not want to get rid of it. Let's go back, reset the simulation. That was a quick one to fix. Press play. There we go. And we have our simulation running up, and we have a crease where we add an angle of 0 to both of ours with a long strength. So we preserve the 90-degree, how they come together, but a 0. Okay, now let's go ahead and set up a 90-degree angle between those two meshes. How can we do this? Well, currently they're both adding 0, so we could add 90 degrees to the first one and leave the second one to 0. So 90 plus 0 is 90 that we add. Set the simulation and start. There we have our 90-degree angle. The other option is, for example, we set this to 0 and we let the other one go 90. Reset the simulation again. We get the same result. What I personally prefer actually is to split the difference. So I'm going to do 45 on each. Split the angle. Instead of 90 on 1, 0, 1, I set 45 to each. Let's reset the simulation and run this again, and there we go. We get the same result. And obviously angles are signed, so if you realize this bends the wrong direction, put a minus in front of it. Minus 45 to this one. Let's get minus 45 to this one. Reset the simulation, run the simulation, and now we're bending in the other direction. Well, I hope this all makes sense and you have as much fun using these as I do, and thanks for watching.